Hi, this is Andrew. We're working on some statistics homework tonight. The next problem that I have to do for my homework is standardized scores. And I have 20 data points on the assignment. So I use an online tool called cram101.com. It's easier than spreadsheets because everything is laid out for me and the formulas are right there. So let's go to cram101.com. This is the lab menu for stats. And what we want to do is come down to standardized scores. There we go. The first thing they ask us for is the number of scores in the distribution, which for my assignment is 20. We'll put 20. And then we need to enter the data. So let's go with 64, 48, 55, 68, 72, 59, 57, 61, 63, 60, 60, 43, 67, 70, 65, 55, 50, hang on there, 56, and 64, 61, and 60 is our last one. Okay, so let's just check to make sure I didn't make any other mistakes in putting the data. Looks pretty good. Now you can always use the one thing that's neat about Cram is you can always use Cram1 to come back and select random data, and it'll populate that with different data until you master the concept. Kind of neat. Right now we're going to concentrate on homework. Okay, the next step is to order the data numerically. So in this next table, we've taken our data above and sorted it from lowest value to highest value. Cram does this really nicely for you. It saves you a lot of trouble. Okay, we've laid out some extra columns over here, which we'll get to in a few minutes. First, the next step then is to compute the mean. So the mean is basically the sum of the scores divided by the number of scores in the distribution. We add all those up, we get 1208 divided by 20. We have a mean of 60.4. And then the next thing to do then would be to take the mean and then calculate the deviations from the mean. We'll go back up to our table. And you can see here's the score value minus the mean. So we have 43 minus 60.4 is negative 17.4. 48 minus 60.4, negative 12.4, and so on. So this is, again, it's handy. You don't have to do a lot of the busy work by using the Cram tool. Okay, so we have the deviations. The next step would be to compute the standard deviation itself. All right, so here's our formula for standard deviation. I'm going to dissect that and solve the various things. So we already have the first value, which is the sum of the scores, and the distribution was 1208. We then need to get the sum of each scored squared. So we'll go back up to our table. And this column right here is 43 squared is 1849. 48 squared, 2304, and so on. So we have all the squares, and then what we need to do is sum those up. And the sum of those will be 73,894. So we have 73,894. The next thing we want to look at then would be then to solve for this right side of the equation, which again, we already have those values. So it's 1208. Square that value and divide it by 20, and you end up with a result of 72,963.2. And then solving for the entire numerator, again, we have all the values. So here's the 72,963.2 we just got. And want to subtract out subtract from 73,894, and that gives us a numerator of 930.8. And then calculating, and for the standard deviation, you need to divide by n minus 1 and then take the square root. And that gives us a standard deviation of 7. So the next step then is to derive the z-scores themselves. We'll click that button. And all we have to do in this case then is to go through the deviations, negative 17.4, divide that by the standard deviation, and then we have a standard score of minus 2.49. And you could proceed through the rest of the data points, and you'll have your standardized scores. There's the table of standardized scores. As a general, rule for me, I always like to print things out to make sure I've, done my work, which you can do with CRAM. So there you have it, the standardized scores.